first thing we're going to look at is rate of change of theta. All right, there are a couple things we need to remember here. First of all, our first rule is read our problem and draw a picture. A couple things we need to know. Tangent of theta is the opposite over the adjacent. The derivative of tangent is secant, and secant squared is 1 over cosine squared. Height is measured in linear units. Okay, Dorothy, who is standing at point A, so we're going to put Dorothy right here. Put her little braids on her. Okay? Standing at point A watches the professor in a balloon rise up from point C. So this is point C. And let's draw the professor in his balloon over here. There's the professor. Okay? Dorothy's watching him rise up. Okay? The balloon is rising at a constant rate of 5 meters per second. So we're going to say, let's just call it the S for side. We're going to say ds dt equals 5 meters per second. What else did they tell me? They told me Dorothy is 80 meters to the east of point C. So we're going to stick 80 meters on Dorothy. Equals D. We're going to call D for Dorothy. D equals 80 meters. Okay? And then it says, find the rate of change of theta. So we want to know d theta dt when the balloon is 60 meters off the ground. So we want to know when S is 60 meters. Well, let's look at this. This is a right triangle, right? All right. So we know this is 60. We're probably going to need that third side. So let's just go ahead and look at that third side. All right. Let's use Pythagorean theorem to find our third side. So I've got 80 squared plus 60 squared equals, well, that equals 1,000 or 10,000. Okay, that's 10,000. Sorry, I know you can't see that. And then let's just take the square root to find the opposite side. My opposite side is 100 meters. So 100 meters is my hypotenuse. So we also know my h for this scenario will be 100 meters when I need it. Okay, so looking at this, we know tan theta equals the opposite over the adjacent, right? Well, in this case, my opposite, even though they told me for the scenario 60, we're going to use S because he's rising, so that can change because we need a formula, S over 80. Take the derivative. Well, the derivative of tan is secant squared. And we took the derivative of a theta, so it's d theta dt equals 1 over 80, because the derivative of S is 1, ds dt. Okay, now, to get d theta dt by itself, because that's what we want to know, we're going to divide by secant squared. Okay, so d theta dt equals 1 over 80 times ds dt. There you go. And then for secant squared, well, that's still divided by secant squared, but remember, secant squared is 1 over cosine, or since this is 1 over secant squared, it just becomes times cosine squared theta. Okay, well, I know something for ds dt. I know my d and my s. I need to figure out something for cosine theta, cosine squared theta. So let's go back to my right triangle. We said my side lengths were 80, 60, and 100, correct? So looking at this, well, cosine of theta, if y'all remember back from geometry, and even pre-cal and even this year, cosine of theta is the opposite, is the adjacent over the hypotenuse. So that's 80 over 100. So all we're going to do is plug in 80 over 100 squared. So d theta dt equals 1 over 80 times ds dt, which is 5 meters per second. And then cosine squared theta, well, that's just 80 over 100 squared. Plug all that into a calculator and number crunch it. And you actually end up with d theta dt equals 1 over 25 radians per minute. So that's your answer. Now remember, I point this out. Point for your answer, point for your work, point for your equation, point for your derivative, and a point for your picture. So even if on your quiz on Friday you just draw pictures, you'll get a fourth of it, or quiz on Tuesday. Okay. A pebble is dropped into a calm pond, causing ripples in the form of concentric circles. The radius of the outer ripple is increasing at a rate of 1 foot per second. So we're going to say dr dt equals 1 foot per second. Let's draw a picture real quick. So we've got a pebble being dropped into a pond. So let's say we have a pond. All right. And we have my ripples doing this. Now, if r equals 4, so 4 feet, what is the rate of the total area of the water being disturbed? So I want to know dA dt. Now again, we're talking about area of a circle. So we're going to say A equals pi r squared. dA dt equals 2 pi r dr dt. Okay? What else did they tell me? Well, we know my r is 1 foot. My radius is 4. Let's plug all that in. So we're going to say dA dt equals 2 times pi times 4 times 1 foot per second. And that's 4 feet, right? So 2 times 4 is 8. So we're going to say dA dt equals 8 pi feet squared per second. There you go. And lastly, we have the altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of a triangle is increasing at a rate of 2 centimeters squared per minute. At what rate is the base of the triangle changing when the altitude is 10 centimeters and the area is 100 centimeters? Well, one thing we need to remember here is we said when it comes to area formulas, all right, product rule, product rule, product rule. So we're talking about a triangle. Now the other thing you need to remember, the altitude is the height of a triangle. So let's draw myself a picture. All right, so picture of a triangle. And we have okay. The altitude, so let's say altitude is height, so we're going to say dH dt is increasing at a rate of 1 centimeters per minute, while the area of a triangle, so we're going to say dA dt is increasing at a rate of 2 centimeters squared per minute. At what rate is the base of the triangle changing? So we want to know dB dt. That's what we want to know. And they told me altitude or height is 10 centimeters and A is 100 centimeters squared. All right. So let's look at my formula. All right. First thing I know, and I may have to continue on another sheet of paper. There's not a lot of room, and Miss Foster writes big. Y'all know that. They told me area of a triangle is A equals 1/2 base times height. So first thing I'm going to do, I'm going to use the product rule and differentiate. dA dt equals, well, the derivative of b is just 1, so 1/2 h dB dt plus, now the derivative of h is just 1, so 1/2 b dh dt. Okay, let's see what I know to plug in. I know dA dt, I know 1, I know my height, I know my area, but I don't know my base. So I'm going to have to plug in a base right there. So let's figure out what the base is. Alright, we're going to have to do some algebra. Alright, so looking up here. Alright, so we know 100, I'm just plugging into area formula, equals 1/2 times 10 times the base. Well, that just gives me 100 equals 5 times the base. So the base is going to be 20 centimeters. So now let's plug it all in. I have my base, I have my height, I have my area, I have my dH dt and my dA dt. So now let's plug it all straight in. So dA dt is 2, so we're going to say 2 equals 1/2 times, well, what's my height? My height is 10. dB dt, oh, that's what I'm looking for. So plus 1/2 my base, which we just found out is 20, times dH dt, which is 1. So let's plug all this in and simplify this. 2 equals 5 dB dt plus, well, 20 divided by 2 is 10 times 1. Subtract 10, and I have -8. So -8. -8 equals 5 dB dt. Divide by 5, and I get -8 over 5. And what is this? Centimeters per minute. I'll put a question up on Edmodo for y'all to answer, please.